All right, so lesson 10 is going to be dealing with graph or functional relationships. So we have dealt with functions, we have dealt with linear relationships, but now we're going to be paying attention mostly to what we call a qualitative graph, and then we're going to see why they're used for instead of actually using values. So we're going to start by going over the intro.
Each graph shows distance as a function of time. One graph shows the function when Mr. Dila is driving in his neighborhood. The other graph represent Mr. Dila driving on major city streets and highways. Which description matches each graph below?
Okay, so we're going to start by answering the first question, which says, what is the slope of each graph? To find the slope of this graph, yes, we're able to do it by using the slope formula, but in this case, since we're going to start at the origin, the best thing to do is just use rise over run. So for the first one, you're going up 40, and then, 30, and then you're going to the right 1. So your slope is going to be 30 for graph A. For graph B, you see that the first point is going to be at 1, 40. Again, if you use the slope formula, you're going to get 40 minus 0 divided by 1 minus 0, and that's going to give you 40. And lastly, the slope of C is going to be 60. For part B, it says, what does a slope mean in each of the graph? So now, to be able to answer this question, we need to put it into context. That means that we're going to look at the y, and we're also going to be paying attention to the x. So we know that we're going to be talking about distance over time. So for each graph, you're going to see that for graph A, he's going to be driving 30 miles per hour. For graph B, he's going to be driving 40 miles per hour. And for graph C, he's going to be driving 60 miles per hour. So make sure that you write that down. Now for part C, it mentions to find the speed shown in graph A, B, and C. We already know because we wrote the slope, and that is the speed. And now it tells you, it says, tell which graph represents driving in the neighborhood, on a city street, and also on a highway. And I want you to think about, for example, driving right in front of the school. If you're thinking, if you see the cars driving right on Winnetka, you see that the cars are driving somewhere around 35 to 40 miles per hour. Some of them get a little too excited and go a little bit faster, but realistically speaking, the speed limit on Winnetka says 40 miles per hour. So that's going to be our city. Now, when we're talking about neighborhoods, that's going to be the smaller streets. Like for example, in this one, the smallest street is going to be Stag. And you're going to see that you don't even have a line in between that is dividing the lanes. So that means that you're going to have to drive at a slower speed. So we're going to put the neighborhood is going to be the slowest. So that's going to be 30 miles per hour. Then the major city street is going to be 40 miles per hour. And of course, a highway is going to be 60 miles per hour. Instead of driving miles per hour all the time, what I did is just write MPH for miles per hour. Now we're going to be dealing with qualitative graphs. In the other ones, we're dealing with linear functions, but now we're going to graph those linear functions and we're going to put it into one graph itself. So it says this is called a qualitative graph because it describes a function visually, not with exact numbers. So let's highlight that part. So it's going to be visually and not with exact numbers. And then it says the sections labeled A, B, and C have the same slope as a graph with the corresponding letters on the previous page. So we're using the information from the previous page, and we know that in part A, this is going to be 30 miles per hour. So this segment is going to be 30 miles per hour. Part B is going to be 40 miles per hour. So you see how the line is a little bit steeper. But now when we're talking about part C, this is going to be 60 miles per hour. And of course, this is going to be a lot more steep. And then the next part, it says qualitative graphs have sections with horizontal segments. So make sure that you have that highlighted as well. And whenever you have a horizontal segment, it's going to mean no change. In this case, we're talking about speed. So during that time, there was no change or movement. And those horizontal parts will be right here between A and B. So at the peak of A and B, and then at the peak of B and C. Now, not all qualitative graphs will be the same, and the next paragraph explains it because he mentions that qualitative graphs can also have curved lines, so make sure that you highlight that part, to indicate that the slope of rate of change is not constant. That means that it's going to be changing. That's why we call it rate of change. And then the graph on the right shows the number of students who are in the school cafeteria between 10 a.m. and 11 a.m. and 1 p.m. on one school day. So you're going to see that is not a constant increase and constant decrease. It's just going to be a fluctuation of numbers. So it goes up and it goes down. Keep in mind that whenever you guys go to lunch, then the line is going to be a little longer, and then when you tell them that lunch is almost over, then it's going to again get filled up. And it says the students go in and out of the cafeteria without following any pattern. The rate of change, the rate is not constant, so this is not a linear situation. The graph shows the following. The number of students in the cafeteria builds gradually until about 12, and between 12 to 1, the number of students in the cafeteria decreases gradually. Okay, so again, keep in mind, I've seen you guys outside. One of your friends says, I'm going to go have lunch, and then you have a group of people that are going to follow, right? So you guys go in groups. Whenever one feels like eating, they will go. If you want to eat early on, you force your friends to go with you early on. And if you don't feel like it because you want to go play soccer or basketball first, and then you want to go eat when the line is shorter, then you're going to have a bunch of kids going in to try to get lunch. Now we're going to be answering question 1. It says, this graph represents a person tossing up a basketball and letting it bounce on the ground. Describe how the graph represents this situation. Whenever you toss a ball, from the starting point, it's going to go up and it's going to bounce. But after the first bounce, it's actually not going to get the same height. It's actually going to be somewhere around 75% of the original one. And then that's going to turn into 50% on the second bounce. And then it's going to become like 25% to eventually the point that it's not going to be bouncing. That's why, as you can see, this graph shows curves with very sharp points at the end, and that's a point where it bounces.
Students in Ms. Blanco's class have 3 weeks to complete their science projects. These graphs show how much of the projects 2 students have completed each day during this 3-week period. Describe what each graph shows.
All right, so when you're looking at the graph, we're going to be paying attention to Lynn first. So for this one, it says your X is going to be the time in weeks. And then when you're talking about the Y, that's going to be the amount of the science project completed. Okay, so we're actually going to draw a vertical lines just to estimate around how much it was completed. So I'm going to just draw a vertical line at the end. This is the completion of 3 weeks. And then I'm going to try to make this as even as possible. That's not very even. Okay, hold on. Let's try that again. So it's supposed to be somewhere around maybe somewhere around here. That's more even. Okay? Now, if you were paying attention about the amount of the science project completed, you see that Lynn originally started with a high, what we can say, rate of change. It's very constant. And then little by little during the second week, it started to slow down little by little. To in the third week, he barely did anything. So that means that he had his project completed pretty much at the beginning of the third week, and then he just needed to finalize the details. Now, when we look at Amy, we're going to try to split it in about 3 weeks. So we're going to say around here and around here. I feel like that looks a little bit even when it comes to splitting. I'm sorry, I cannot draw vertical lines straight. But when you start this, Amy reminds me of a lot of you guys. Starts very, very slow. Like the first week, nothing. But like video games and watching videos. She wanted to watch videos on how to do the science project, and then she just started watching videos about puppies. Okay? And then the second week, you see that she picked it up. She did a little bit more, but she still didn't get much done.
She realized that
The majority of the project was completed at the end of week 3. So that means that most likely on Sunday night she didn't sleep because she needed to get this done. Because if you see, even halfway point between week 2 and week 3, she still did not have most of the things completed. The rate of change in the last 3 days for her were pretty much a rate of change that Lynn had in the beginning. Now, what we just covered is pretty much in the analyze it part. They mentioned how this breaks down and mentioning how Lynn was a little more effective while Amy was just a procrastinator and left it at the end. Okay?
each of the thirds represent 1 week. Lynn's graph is steep in the first third and somewhat flat in the rest. That means she did most of her work on her science project in the first week. Amy's graph is the opposite. The steep section is in the last third. She did most of her work on the project in the third week. The graph shows daily sales of frozen yogurt at a new store during a 6-month period, starting an opening day on April. Describe what is happening in the terms of this situation for each section of the graph.
So if we're going to start in April, we're actually going to label this graph a little bit more. So we're going to start by putting the beginning month as April. So I'm going to put right here April. That's going to be your first month. Now we're going to try to divide this as evenly as possible. You know that it lasted for 6 months. So right here at the end. Now from April to October, we're going to split this as evenly as possible with all the months in between. So let's try to make sense of this data. We know that we're talking about a shop that is going to be selling something cold. Now, in April, if you're not aware, April 22nd, that is the beginning of spring. During springtime, the day is going to be longer. Most likely, you're going to be wanting something cooler. Now, but during this time, you also have the fact that you're going to have longer days because, again, the sun doesn't set until later on in the day. So during that time, yes, you can actually see the sales are going to increase. And then in May, you see that it actually starts picking up speed. They're actually selling a lot more. This is going to be a lot more steep compared to A. Now, keep in mind between May and June. During this time, this is finals week for a lot of the schools. College is completely out in the beginning of May. So a lot of people, especially with longer days, hotter weather, they're going to be selling a lot more during this time. Now, at the end, if you actually see from June to August, you're going to be selling at a constant rate. This means that you guys are going to go out and begging your parents and crying for your parents that you want to go out, you want to go out, you're going to go out. They're going to take you to Menchie's and buy something, right? So during this time, it's going to have a constant rate, especially with the weather being somewhere between 90 and 100 degrees. People are going to be looking for something cold. So we're trying to make sense of the graph, even though we don't have any numbers. And then right here, at the end of July, you can actually see how sales start dropping. After June and July, your parents are also not planning on taking you out as much because that means more money, and then they have been spending a lot of money in you. And summer is not cheap for them because the more you're home, the more you eat. That's how it is. If you're not home, you don't eat as much because you eat at school. If you're home, you're going to be eating everything that you find, usually a bunch of boxes of cereal or cup of noodles. So your parents are not going to be willing to take you out as much. But during this time, right at the end of July and August, you see how this is also dropping. During this time, like at the end of July and August, your parents are usually buying you school supplies and your uniform and your backpack. And I hate those shoes. I need to get new ones. It's like, okay, like it's going to get annoying, but that happens. Now, in the middle of August, you guys are already in school. During this time, you guys are not going out as much, and also the weather is going to start changing. So during this time, you can actually see that this is going to be a constant sell. They're not going to be selling as much. Now, if we kept going with this graph, you will see that this graph will be dropping and then dropping and then dropping because nobody wants to go get something cold on a rainy day. That's how it is. Now, what I need you to do is I need you to answer questions 2, 3, 4, 5, and 6. And again, the only thing you're going to be doing is using the explanation and the information they already gave you to answer these questions. And I want you to try to answer question number 7.
Angela and Lori are hiking a mountain. The beginning of the trail is not too steep and they start out at a quick pace. They stop and rest for several minutes, then climb up a steeper part of the trail at a slower pace until they reach the highest point on the trail. They rest again before climbing down on a constant rate, faster than they climb the mountain. Sketch a graph to show the distance compared to time.
Okay, so we're going to highlight the information that we need. So the first part is not too steep, and then they start out at a quick pace. And then they're going to climb something steeper at a slower pace until they get to the highest point. And then they're going to rest, and then they're going to climb down faster than they climbed the mountain. Okay, and we're going to be comparing again the time, distance, and time. So the book already breaks down everything for you. It starts by saying that A is going to be they're going at a quick pace at a segment that is going to be steep. And then if you look at the bottom, that's exactly what's going on. Right here in A, they start from the bottom and then they're going to go up at a constant rate and it's somewhat steep. But then for part B, it says before climbing a steeper part, they rest. It makes sense. Again, you're not going to be rushing up if you're already a little bit up from the first part. And now they're going to rest in part B, and that's why you see that it's a different color. This is the blue segment. And then if you're climbing something steeper, it's going to require more force. It's going to require more dedication. You're going to do it slower. So that's why you see that even though it's steeper, and this part is actually taking a low pace. And then when they get to the top, they rest. Now, when you're on top of a mountain and you have to go down, you can actually do that at a faster rate, right? You can just roll down. Or again, when you are preparing, you just like hiking down is not going to be too challenging, and then you're going to do this in less time than going up. Okay.
Like this one. Mrs. Eliza does errands on her lunch break. She starts walking quickly but then has to slow down as the sidewalk gets crowded. She stops at a store and picks up a few items. She walks quickly back to the office since there is no longer a crowd.
So we're going to start highlighting that she's walking quickly. And then it's going to slow down because people are in the way. And then she has to stop at the store. And then she walks quickly back to the office. So when it says describe the first segment of the graph, what should the slope of this segment be? All right, so the slope for this one is going to be a steeper line or steeper slope compared to the rest of the story, because he mentions that she is moving quickly. Now, it says, what should the slope of the graph for the second segment be? Now, the second segment mentions that she had to slow down because people are like blocking her. So it's going to be, the slope is going to be less steep. So less steep than the first section. And then it says, describe the third part of the story and tell what the graph looks like for this section. So we know that she stopped at the store. She wanted to, I don't know if she was running errands or just being a shopaholic. But again, she stopped to get a few items. So that means that it's going to create a horizontal line. Remember, the horizontal lines have the slope of 0, which means that there's no change at all. It's not going down, it's not going up. She just stopped moving, which means this is going to be a horizontal line. And then the next portion says, describe what the graph should look like for the last segment. And it says she quickly walks back. So this is going to be as steep as the first line, but going down. So this is going to be, again, a steep line like part 1. I'm sorry. Part 1, but going down. Now, we're going to work on 12 and 13 together.
Use the answers to problem 8 through 11 to sketch a graph for Miss Elijah's distance from the office over time. Draw your graph in the space to the right.
So we're going to start by drawing the Cartesian plane. Okay. We only need to leave our x and y. Now we're going to be comparing the distance from the office. So this is going to be distance. I want to put slash or in parentheses office, so we know that how far away she's from the office. And then our x is going to be the time. Now, they just mentioned that she went, had to slow down, stop, and came back. They never gave us units, so we're not going to put any units. We're just talking about time in general. Now, the first point is going to be at the origin because, again, she started at the office, so that's going to be the point 0, distance from the office, and time. Then we said that she went quickly, so we're going to go up at a constant rate of change. But then she also had to slow down because people were like blocking her way. They were being messed up. They don't know when you're rushing. And then she stopped for a period of time. So we're just going to make a horizontal line. And then we're going to go back down quickly. So we're just going to make this line quickly. So our line needs to look something like that. Now, for number 13, I want you to do number 13 in your notebook.
Pablo starts walking to the park. Halfway to the park, he starts jogging. When he gets to the park, he stops to rest. Finally, Pablo walks home at the same pace as the first part of his trip. Sketch a graph that shows Pablo's distance from home compared to time. Draw your graph on a separate sheet of paper.
Justin takes the bus home from school. He gets off the bus, walks a short distance to his friend's house, and stops to talk. Then he walks to his house. Sketch a graph for this story that compares distance from home to time. Explain your graph.
Okay, so distance from home, taking a bus home from school. So that means that they're far away from home. And then he tells you that after he gets off, he needs to walk a short distance. That means that he's not going to be moving at the same speed of the bus. And then he's going to stop to talk. More chisme. Then he's going to walk to his house after he has gossiped with his friend. And then we're going to graph this. So originally, he was in a bus and the bus moved at a constant speed. So we're going to put that constant speed going home. Try to make it as straight as possible. Whenever he's walking, he's not walking at the same speed. So this line is going to have a smaller slope. And then it tells you that he's going to start and chat with somebody, or He may be talking to himself, but we're going to just keep drawing a horizontal line, and then he's going to keep going down until he gets home. Okay, so this is how our graph is going to look like. Eventually he'll make it home.
This graph shows a carpenter's distance from the ground while working on a house. Describe what could be happening in each section of the graph.
So since he's working on a house, and we're going to highlight that part, we're going to be paying attention to the distance from the ground. That means that at some points he's going to be working on the ground level, right? But sometimes he's going to be really, really high, and he needs to go up at a constant rate. He's going to be at a higher point, and then he's going to come back down. So I need you to give me a story that will represent this. So in your stories, things can always be a little bit different. You can just quickly say that the carpenter was in the first floor. That's why the distance from the ground was 0 right here. So he was actually working on the first floor, and then he went up to the second floor to find one of his tools. He found one of his tools, then he came back down, worked for a little bit, and then he went back up to drop off his tools, because his tools are being like saved in the first floor. You can also mention that the carpenter started working on the ground, and then he went up to put a beam on the roof, and then he went back down to get more material. After he got the material, he went back up to keep working on the beams. So there are many different options, as long as you mention that he started at the ground, he went up on a ladder, on an elevator, whatever you feel like, and then he went back down, stayed for a little, up, and then he stayed. Now let's go look at the next one. Let's look at number 16.
This graph shows Mr. Tossi's distance from home as he drives to work one morning. Which section of the graph and corresponding description match?
Okay, so now the first part is, let's pay attention to the bottom part where it talks about D. It says Amir chose D as the correct answer. How did he get the answer? Okay, so most likely this one is not going to be our answer. Now let's read A. It says section A, so this part right here, it says that he leaves home, and it makes sense because he mentioned distance from home. When he's at home, it's going to be at 0. If he's leaving home and he starts driving slowly and then picks up speed, this is not picking up speed. This just looks like it stayed the same. And then, so that shouldn't be the case. Then B, it says, continue driving at a constant speed. That means that it's going to be a horizontal line all across. So, not happening. Now, C tells you that he forgot something at home and then he returned home to get it. And that makes a little more sense because he mentioned that he went up, then as he's driving, he forgot something home. So he came back down, and then he went back to work after he picked up his cell phone, his keys for the office, or his wallet because he wanted to buy something to eat during lunch. Doesn't matter. All right.